Now that we understand how geologists talk about rock faces or slopes, it's easier to talk about how geologists describe faults. So I've added in a second component here, which is this top wall or hanging wall to this fault. And what we're going to do is explore different types of faulting and the associated earthquakes. So when you think of faulting, you might think of the crust sort of separating like this. And while that does happen, say, at mid-ocean ridges, where we have extension of the crust, usually earthquake-generating faults involve slip with rocks rubbing against each other. And notice there was no rock rubbing against each other when I did that. So we're going to talk about two components of slip, and those are strike slip and dip slip, that are associated with earthquake-generating movement on faults. So the first type of slip I'm going to generate is strike slip, and I'm going to move this hanging wall off to the right relative to the footwall, and I'll set the offset to 30 feet. And one thing you should notice is this river has now been offset a particular direction. So if we look at this river head on as if we're going down the river, we can see we now have to take a left turn to go down the river further. And this is what's known as a left lateral strike slip fault, because we have to make a left turn to get to the same feature on the other block. And you'll notice if we rotate this entire diagram the other direction, it still looks left lateral. So it doesn't matter which side you're looking at it from. I still have to make a left turn to continue down the river. So I'll get everything reoriented back to their original conditions, and then I'll do the other type of strike slip, which you can probably guess, is a right lateral strike slip fault. In this case, notice when we look around, we have to make a right turn to get to the same feature on the other side of the fault. And again, this applies no matter which direction we're looking at those features from. So that's strike slip faults. Strike slip faults are mainly associated with shallow earthquakes. They can occur at transform boundaries and things like that. And they are generally less powerful than the types of earthquakes we're going to show next, which are dip slip faults, because these tend to involve either compression or extension of the crust. All right, so to generate a dip slip fault, what I'm going to do is I'm going to move this hanging wall downward or upward along the fault trace. So we'll add about 10 feet of offset. And notice we've created a little bit of a waterfall in the center here. One side has moved down relative to the other. The other thing I'm going to show, I'm going to bring in this measurement that shows baseline distance. And you can think of this as if I had two telephone pole, or if I had a telephone pole at either end of this diagram, how long would the telephone wire connecting those two poles be? So if I undo that fault motion to get everything back to normal, we can see our baseline distance starts at 200 feet. So if we have dip slip like the type we just saw, which is known as normal faulting or extensional faulting, what we will see is that the baseline distance increases. So when we have this type of normal or extensional faulting, what we would expect is probably that power line is going to snap. All right, so that's one type of dip slip, normal or extensional faulting, where the hanging wall goes down relative to the footwall. Now we're going to look at the opposite case, where the hanging wall goes up relative to the footwall, and you might be able to guess what's going to happen. So again, I'll move the hanging wall up along the fault by about 15 feet. And what you should see now are a few different things. One, we created a waterfall again. This time, though, we decreased the distance between the two telephone poles, so you can imagine our wire gets quite loose at this point. We've decreased the baseline distance. So this is called compressional or reverse faulting, and you can tell why it's called that because it's essentially compressing the land into a smaller area. Now when we have real faults, they can have multiple components of both compression or extension and strike slip, but notice the strike slip has no effect on the distance, the compression or extension. So hopefully that helps with understanding faults a bit and thinking about how they can move in different ways. And if you have any questions, please feel free to leave them in the comments.